Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
With folks at MSR and with other colleagues amongst yourselves. So now I'd like to introduce you to Dr. Rick Rashid. Dr. Rashid is a Senior VP in charge of Microsoft Research worldwide. Dr. Rashid also founded Microsoft Research in 1991. And prior to Microsoft, he was a professor of computer science at Carnegie Mellon University. So please welcome me in, please join me in welcoming Dr. Rick Rashid.
Thanks, Alish.
Thank you.
Well, Tom got me very worried because he said that if you wear the light blue shirt, everyone's supposed to be able to ask you what's going on, and you're supposed to know. That won't work for me. So, you can ask me any question you want, but I probably don't know much about the logistics other than what you're going to get from Tom. I don't know why they didn't give you a dark blue shirt. I guess maybe they decided that I was more of an organizer kind of person. I want to give you and pass on my welcome to be here for this Faculty Summit event, both from Microsoft Research and from Microsoft Corporation. We've been doing this for a number of years now. In fact, I was talking with my wife, Terry, about the fact that, it's been about 6 years that we've been doing these events and how the first year was fairly small. And she looked at me and she said, oh, yeah, I remember that. That was the year it didn't work as well. Right? You always get this sort of, unfortunate honesty from your wife. But in any case, I think we've gotten better as the years have gone on, and certainly the event this year looks to be pretty incredible. We've got a number of different tracks. We've got a lot of great speakers and some pretty exciting things that are going to be going on, plus the introduction of our faculty award, new faculty award winners in a little bit. Now, this year for Microsoft Research has just been an amazingly good year. We've been publishing more this year than we've ever done in the past. We've been continuing to grow. And in fact, I was mentioning to Richard Newton at Berkeley the fact that we've grown this year by about the size of Berkeley's computer science department. And we'll probably continue to do that in the coming years. It's been a very positive year for us in terms of growth, not just in the United States, but also outside. We opened up our research facility in Bangalore, and we already have about 20 researchers there. So I'm very excited about that as well. And it's also been just, if I look at what's been going on in terms of our recruiting, the students that we've been seeing, this has been just a spectacular year. I think it's the best year I've personally seen in terms of PhD recruiting in the years that I've been in the field. And I don't think it's just me. I've talked to a number of my colleagues in academia and industry, and they've also made the same comment. At the same time, while things are going great in that respect, and certainly the field has continued to grow, Microsoft's employment is growing dramatically. We've hired more people from college campuses this year than we've ever hired before. At the same time, there's a lot of negatives going on, and that also worries me. If you look at the number of students that are going into computer science, that's been dropping dramatically. And it has been something that has concerned me. And that I've been speaking about very publicly, and that Microsoft as a company, we've been putting a lot of energy into in terms of public policy and speaking to the community and trying to figure out what we can do about that. There's also been, I think, a sense that the funding situation in the field continues to be a problem and perhaps is even getting worse. I've seen some information recently gives me the impression things are getting worse there. And so again, those are areas that concern me a great deal and things that we really have to address. What I'm hoping from this event is to really be able to continue a dialogue that we started 6 years ago with the academic community, to really share what are the great things that are going on, what are the exciting new areas of work, and there's many, many exciting areas of work in the field and many new exciting things that are going on. Share that, talk about what some of the opportunities are together. At the same time, also to share our best ideas about how to make sure that computer science continues to be a vibrant and exciting field for years to come. So as we go through the next couple of days, I'm hoping that both among yourselves and in talking with people here at Microsoft, we're able to really talk about those issues, look at what we can do to really help move the field forward in an important way, and to make a difference as we try to make sure that computer science stays one of the top areas that young people want to go into, and one of the areas that continues to be the most vibrant in the field of science. Now, I have the distinct pleasure of being the person who gets to introduce Bill Gates and Maria Clave for their session this morning. We're doing something a little different this time. We're going to actually have Bill and Maria on stage having a conversation about some of the subjects that they think are the most important right now to be talked about. And for those of you who don't know Bill, I don't think there are probably very many of you that are out there. He's our chairman and chief software architect, and has really been a participant in this conference for the last 5 years or so. And I think people have really enjoyed the opportunity to interact with him. Maria Clave is Dean of Engineering at Princeton. And if you don't know Maria, she's an incredibly vibrant and exciting person. She has a tremendous amount of passion and energy. I happen to share duties with her on the Board of Trustees of the Anita Borg Institute for Women in Technology. And I could just tell you from my experiences with Maria, the passion she has around education and students and issues such as gender equity and diversity is just tremendous. So with that, let me bring Maria and Bill on stage, and I'll get off, and we'll have them have their conversation. Thanks, Maria.
Thanks, Rick. So this morning, Bill, I'd like to start off with a really important question. How many of the Harry Potter books have you read so far?
Well, this is a phenomena that I'm going to have to get myself immersed in. I read 2, and then my daughter decided they were a little too scary. But now I understand even adults are supposed to read them. In fact, I'm curious, what do you think is going to happen? What would you like to see happen in the Harry Potter series?
Well, I have one special dream, and I'd really love to see Hermione choose to become a computer scientist. I think that would really turn around our problem, especially for young girls.
Good. Even Harry can do it, too.
That would be great, too. After all, we all know that the magic in the future comes out of computer technology, especially computer software. Let me move to a slightly more serious question. As I'm sure you know, one of the biggest concerns of computer scientists in the United States is the decline in federal funding for academic research and graduate education. We've taken the liberty of excerpting a few statements from a recent article by Ed Lazowska and Dave Patterson, 2 of my favorite computer scientists. Their article is entitled "An Endless Frontier Postponed." And from the article, they say, U.S. IT research grew largely under support from DARPA and the National Science Foundation. NSF relied on peer review, whereas DARPA relied on my eyes, I'm getting old, and so I have to bring these notes closer, bet on vision and reputation, complementary approaches that served the nation well. Over the past 4 decades, the resulting research has laid the foundation for the modern microprocessor, the Internet, the graphical user interface, and single-user workstations. It has also launched new fields such as computational science. Virtually every aspect of IT that we rely on today bears the stamp of federally sponsored research. However, in the past 3 years, DARPA IT research funding at universities has dropped by nearly a half. Last year, NSF supported 86% of the federal funding for fundamental research in IT at academic institutions. The funding rate for competitive awards in the IT directorate fell to 16%, the lowest of any directorate. The average funding rate is close to 30%. So, why do you think the government should be spending money on computer science research in tough economic times? What does the public get out of federal funding for research?
Well, I think the payoff, if there's any place you can say there's been a dramatic payoff, it's in computer science. You know, the United States in the 1980s was viewed as falling behind. Japan had a better industrial model. You know, the U.S. just was going to lose industry after industry, and yet what really happened in the 1990s was that our economy created more jobs, you know, new companies, lots of amazing leadership things happened. And I think you can really point to the DOD and NSF money that went into computer science work as being one of the key elements that allowed us to turn what was a period where people thought we were falling behind into preparation for one of the greatest success periods the country's ever had. The amount of money we're talking about here is not gigantic. I mean, compared to, say, the government budget as a whole or the defense budget or even research as a whole, the portion that computer science really should get is not that gigantic. But to have it decline is really bad. And part of the reason it's hard for people to see the decline, I think, is that there was all that DOD-related money, DARPA primarily. But you know, I remember when I was a computer science student, all the reports would have things like, you know, thanks to the Office of Naval Research. And I always wondered what the heck, you know, was the Office of Naval Research doing on speech recognition or linguistics. But, you know, what the heck? It was good money. And so we've been able to draw on all those different sources. So some of those have become shorter term or more focused. The numeric impact on are we really tackling these frontiers has been more dramatic than I think people realize. And so, you know, it's kind of a crime that at the time when computer science is about to solve the most interesting problems, and when computer science is not only an interesting field of its own with some exciting problems, but it's also becoming the toolkit for all the sciences, where biologists are turning to us and saying, okay, how do you find the pattern in this information? Or astronomers or physicists, or you know, basically all the sciences are becoming very data-driven. You'd think, wow, there'd be a shift of, you know, NIH money into computer science techniques and standards and things like that. That's also not happening to any significant degree. So
why is this? I mean, what are we doing wrong? I mean, I agree completely with you that computer science, I find it hard to imagine any field more important to invest funding for research in because of its importance both at the core of computer science in terms of sort of what we're going to be creating that's going to drive industry, the economy for the next 10 years, but also its applications in other areas. So what is the computer science community doing wrong?
Well, I think there's two boundaries that we have to be very clever about. One is the boundary between academia and commercial innovation, and the other is within companies between their research-oriented groups and their product-oriented groups. And if you have famous stories like Xerox, where they, you know, funded a lot of research and it was very helpful to Apple and Microsoft, you know, that doesn't make business managers think, wow, I'm just rushing out there to increase this big research budget. That's why Microsoft is trying to be a fantastic example of how you can manage both of these boundaries. First, being able to say that the best investments we've ever made as a company is having our Microsoft Research Group, and that the impact that has on our products over the long term is amazing. But even within, say, a 2-year period, a lot of good ideas flow, and not just from the Redmond lab, from all the labs that we have, which are sort of four significant labs now. So we're saying to companies, hey, you ought to invest more in R&D. This is defining the future of the company. It is our competitive edge, is that we're out there on the frontiers. And we're always surprised, at least in our field, our competitors, if you put aside IBM, that's kind of a special case, the amount invested in research is very small. You know, I'd like to see that change. I think it's a huge mistake on their part. The boundary between academia and us as a company is another one that, you know, we've tried to make that an extremely fruitful dialogue, events like this being part of it. And I think we've had spectacular success. You know, our ability to fund certain faculty activities and fellowships, and not have Microsoft Research think of university work as being in competition of what they do, but rather perfectly complementary. So, you know, even if we're pursuing, you know, one way of doing AI internally, if there's another way that's making better progress outside, I want to know about it. I don't want my research people to sort of suppress this other approach. And so, you know, I didn't know when we started out, would this be give us more visibility into the world of academia, or in the extreme case, it might actually give us less visibility. I think that's worked out very, very well. So, you know, we'll certainly be as strong an advocate as we can be that the government's making a mistake here. And, you know, throughout the world, I think governments should fund computer science research. I think in terms of creating great jobs, great companies in their area, what other area would people be funding? This is the change agent of the time. This is the thing that will drive forward. Even just say you were only going to do it just for education, to build the tools for the future of education. You'd want to fund it just for that one little piece alone, not to mention
healthcare,
e-government,
environment, energy, etc.
Yeah, modeling the world. You know, it's about time we understood things like the CO2 cycle and stuff like that. And definitely, computer science will be at the heart of that. So it is an incredible paradox, and you need examples of cases where it made a big difference. And certainly, you know, our company wouldn't exist without that funding that took place on those basic advances.
So let me go to the other half of the crisis in computer science. I mean, I think, at least within the U.S., but I believe it's also true in other areas of the world, not only are we seeing a decline in research funding, but perhaps even more worrisome, we're seeing a huge decline in interest in studying computer science. So just to give some data, the popularity in the U.S. of computer science as a major for incoming college students has plummeted. It's fallen more than 60% between 2000 and 2004, according to the Higher Education Research Institute at UCLA. On the other hand, according to the U.S. Labor Department, the fastest growing jobs throughout 2012 include data communication analysts, health information technicians, and computer software engineers. The most recent numbers for U.S. employment in IT are the highest ever, up more than 5% since the peak of the bubble in 2000. In addition, salaries in the IT area have continued to grow by a compound growth rate of 4%. So it seems that there's a huge mismatch between the demand for graduates with these skills and what we're willing to pay graduates with these skills and the interest among our youth. Do you have a sense of what's going on here? And, you know, I mean, should we be really worried about this?
Well, I'm certainly very worried about it. You know, Microsoft is trying to hire every great college graduate who has basic computer science skills and, you know, we think is highly talented. And, you know, when I sit down and review projects here inside the company, the topic that always comes up is how's the hiring going? You know, we've got open headcount. These are super well-paying jobs. You get your own office.
No cubicles?
Yeah, we're not big on cubicles. I'm not. Other people like it that way, but we've always believed that developers should just have the quiet of their own office, and so it really is gating the speed at which we do things. I think there's two sources of talent coming to work here. One, of course, is native-born talent, which will always be the dominant part. And there we have to have the interest level and the excitement be high. And then the other is foreign talent coming in at various levels of the education system or coming in as part of a career move. And in both cases, what's going on is very troubling. You know, I think the fact that so many smart people were willing to come to the computer science departments in this country, and many of them stay and take jobs. That was a huge win-win. You know, great for the country, great for those people. I know when we were going to start up in India, it was because we'd had really good people here who came from India, wanted to go back, that became possible. And so that worked out very well for us. Likewise, the same thing in China. You know, some people say, well, doesn't this mean there'll just be a shift to Asia of a lot of this activity? And there will be some, but if you take a company like ours, we're always going to have the vast majority of our development taking place in this location. We like to do things in a unified way, and so even though India and China are going to grow quite a bit, it's a big problem for us that we can't get these great students. And I say to myself, what are these other fields doing? I mean, what's going on in, well, apparently the fastest growing major is physical education.
No.
And so I think, wow.
I thought it was economics.
what is going on in that field? I mean, are they making breakthroughs like speech recognition or artificial intelligence? Or, I'm dying to see these new games they're inventing, new rules. And I think, the poor Chinese, they don't realize this is the coming field. And they, 10 years from now, they're going to wake up and say, oh, no, physical education, we completely missed that activity.
Oh, so let me ask you, when Microsoft, are you finding enough people to hire in the U.S.? And
no, absolutely the answer is no. We have this interesting paradox where in China and India we can get lots of engineers, but getting people who have sort of what we call program management type skills or general management type skills, it's very hard to find enough of those. Whereas here in the United States, we do pretty well at getting people with those skill sets, but then it's just the engineering. We're very short of what we'd like to get. And so the competition for somebody who's got the right background is just phenomenal.
So describe for me the perfect engineer that you'd like to hire. What kind of skills, capabilities, talents, so on would they have?
Well, when we first started the hiring, doing university hiring, which was all the way back in the 80s, where we really started putting a program together, we knew that we weren't going to get, we weren't looking for a specific skill. It wasn't like, do you know how to write C programs or something like that. What we wanted was somebody who understood the field, the idea of algorithms and programming, and that they had done some projects that we could ask them about to get a sense of their depth of understanding. Did they really model out the whole problem and try something? For us, it's ideal if they can learn. They don't just program in these garbage collected languages, but they actually get some sense of, hey, underneath it all, there really is a notion of resources, memory resources, computing resources, things like that. So it's a tiny bit of a concern for us as the curriculum doesn't teach you what are the basic mechanisms. So we'd like to see more of that. We'd like people to have written, reasonable programs. The main problem being that if they haven't done some of these things, it's harder for us to get a sense of would they really enjoy this for the long run, and do they have the type of discipline it takes to be very good at doing that. And it doesn't matter what the specifics are, but some degree of thinking through a tough programming problem that then, as part of the discussion process, we can find out how they like that. The one thing that has worked very well for us is the intern program. Today, tomorrow, 2 days, I'm having interns to my house. We actually have 4 of these things because I try to have, it's about 1,200 interns will come over.
That's a lot of people at your house.
Yeah.
It must be a big house.
It's a lawn. Actually, it's more on the lawn than in the house. So it's 300 a night, but it's a tradition. And it's fun for me to hear what kind of questions they ask, which companies they give me a hard time about, or which activities.
Okay, which companies do they give you a hard time about?
Well, there's the one that's fattishly hot right now.
Fattishly hot. Get that one.
And there's always one like that. Google's, sort of has that pole position right at the moment. But they don't ask so much about that as what are the interesting things, what should they do in their career? A lot of good questions.
So one of the things that we all know is that as fields go, computer science probably has the most rapidly changing content. And it's just technology evolves so quickly. And I both as head of a computer science department and then now my second job as dean, having computer science departments, I would always get into these discussions with people in the math department saying, it makes sense that your people teach more courses per semester than the computer scientists do because you're still teaching the same courses that you taught 50 years ago. Whereas in computer science, you have to continually redevelop material so that you really are covering the most up-to-date things. And I wondered if you had just ideas that would help us, or whether Microsoft has ideas that might help computer science departments stay on top of the most recent technological developments.
Well, certainly it's the goal of our university relations group to make sure that we're talking about what we think the state-of-the-art problems are, finding out from the universities, and a lot of dialogue back and forth about that. In a certain sense, yeah, the curriculum has changed, but say somebody came for an interview and they said, hey, I read The Art of Computer Programming. That's all I ever read. I did all the problems. I would
hire them right then. Yeah,
right.
So would I.
Even if they didn't do the double star problems. I mean, just the fact that they'd read the whole book. Those are the kinds of things you need to know to be a good programmer. Actually, you don't even need to know. There's some of that you don't even need to know. But the kind of algorithmic thinking that's promoted there. So in a sense, we want to teach the same thing, but we'd like to teach it in a form that's most interesting. So, for example, the idea of, okay, let's take some of those basic ideas and program a robot to, go somewhere or figure something out. You want to inject that into the field. But what you're really teaching the person about design is pretty much the same as you wanted to teach them 30 years ago. I mean, we still haven't, gotten past that. And so, there may be rich run times that we can give to universities that make sure that the person learning those things feels like they're doing something very cool and very interesting.
Well, let me ask you a little bit, and this sort of comes back to the research again, because throughout my life as a computer scientist, there's been the sense about what is core computer science and then what is sort of cross-disciplinary or bridging into other areas. And of course, my experience has been that, 20 years ago, graphics wasn't core computer science and neither was databases, and now they are, right? So what's core computer science keeps on going like this and this and this, which I think is actually great. But one of the things that's we've been thinking a lot, both at the education level and at the research level, is the extent to which education and research should be focused on the computer science discipline, or the extent to which it should be bridging and application-oriented, so for instance, bioinformatics or computational science. And one of the issues, coming back to the research funding, is that there's a lot of concern that even at NSF, much of the funding for research has been focused on cross-disciplinary areas, and that we worry that if you focus so much on that, that the funding for the core research areas, the traditional areas, whether it's graphics or theory or systems, is really being hurt. And so I'm interested in what Microsoft's position is on this, both in terms of where should we focus our research priorities within the field of computing? And also, when you think about it at the educational level, is it better to graduate somebody who has a double major in biology and computer science, or better to graduate somebody who is really fixated on computer science?
Well, there's a lot of super important problems that are pure computer science problems. I get a chance to talk about how the world's going digital, and we're going to have digital lifestyle, digital work style, and everything, video, audio, how you're going to store those things, deal with your memories. But in order for that dream to come true, there's some very tough problems that just haven't been solved. Problems in security and privacy, which that's computer science. Problems in data organization, how you navigate that data, how you present the information. We have an interesting dilemma coming up in that clock speeds of microprocessors aren't going to be going up much from about 3 to 5 gigahertz. And so what the chip guys are giving us is lots of processors, and they're saying, hey, you computer science guys,
figure out how to use them together.
It's about time you guys figured out how to take N processors and get N capability out of these things, and now just go do that. Well, that turns out to be one of the great unsolved problems, and yet there's no way around it. I mean, literally, Intel is going to have 32 processor systems running at 5 gigahertz, and that's what a modern PC will be, say, within 4 or 5 years. So, we certainly need brilliant people thinking about that problem. What's going to go on with it? All of the issues around natural interface, vision, speech, ink, modeling, those are areas where the economic value of getting those things right, whether it's Microsoft or anybody else, it's the next 10 years that it's interesting. I think if I'd written down, in the late 60s, early 70s, the interesting problems in computer science, if anybody had, that we could say that a small percentage have been solved right now, but that a very high percentage will be solved in these next 10 to 15 years. And so, that should make it...
only if we work on them.
Oh, that's true.
I mean, only if we have funding for the graduate students to actually work on these things and so on. And
no, but people should want to work on these problems. I mean...
yeah, of course they should.
Well, this is the most biased crowd in the world, perhaps. Yeah.
Well, let me talk about this issue about wanting to work on these problems, because, I have managed to succeed in convincing one of my 2 children to study computer science. I'm glad I at least got one of them. The other one happens to be a female. And, I sometimes tell myself that the reason she doesn't want to work in computer science is because she sees her mother as a pioneering rebel. And so she wants to be a rebel. And her mother wants her to work on computer science. And therefore, she's going to work on anything else. But I know from having spent a lot of time both talking to my daughter and her friends, but doing broader research as well, including surveying thousands of high school students, that one of the issues that really stops a lot of, particularly young women, but also minorities and others, from wanting to study computer science is the image of the computing career and what a computing professional is like. And so just to quote some of the young women I've spoken to over the last 10 years or so, they say things like, well, if you're going to work in a computing career, all you're ever going to do is program. It's going to be, 24/7 programming. You're going to be pale because you never get outside. You never talk to anyone. Then you have to work with all these horrible other people who don't have a life. They don't know how to talk. They don't know how to do these things. And besides, it's boring. I don't know. Anyone out there had this conversation with someone? So, I know what my field is like. I know it is the most exciting area in terms of affecting the world. I know that people work in teams. I know that, yes, you have to be creative, you have to be smart, you have to be disciplined, all of those kinds of things, but you also need to know how to communicate. What can we do about creating a more positive image for our profession? And what is Microsoft doing?
Well, here is another example where I think the best thing Microsoft can do is just share the examples of what kind of jobs these are and how interesting they are. If you take, I spent a lot of time last week over in the Microsoft Office group. They're working on this new version, and it's so exciting, to walk the halls and have people show me the feature they worked on and talk about, what customer meetings they were in that led them to believe they ought to do this thing and what other group they talked to. I mean, the nature of these jobs is not just closing your door and doing coding, and it's easy to get that fact out. And in fact, the greatest missing skill is somebody who's both good at understanding the engineering and has good relationships with the hardcore engineers and bridges that to working with the customers and the marketing and things like that. And so that sort of engineering management career track, even amongst all the people we have, we still fall short of finding people who want to do that. And so we often have to push people into it. And so I'd love to have people who come to these jobs wanting to think of it as a lot an exercise in people management and people dynamics as well as the basic engineering skills. That would be absolutely amazing. And we can promise those people within 2 years of starting that career, most of what they're doing won't be coding, because there are many career paths, say within that Microsoft Office group, where you're part of creating this amazing product. You get to see how people use it. You get to then spend 2 years, build another version, and really change productivity in this very deep way. Take some big bets on what you're doing and do some things that are just responsive to what that customer wants. So I think if people understood, they wouldn't feel this way at all. In fact, they ought to go learn about these other jobs, like
being a lawyer, for example,
or going into a sales job where you're always just measured by a number, basically. Okay, give me a bigger number, and you're not doing anything that's really all that new and different. I just don't get it myself, and I don't know why it's not evident to people. We do, when we do university recruiting, we have the people who are doing these jobs go out and do the interviews. We make sure they allocate time to do that. Now, by the time we're going out and interviewing, of course, we've already lost a lot of the...
Well, they haven't studied computer science in the first place. Well, so one of the things that within my lifetime has been a huge change is the number of women who've gone into medicine and law.
Phenomenal.
It's now 50%.
It's greater, yeah.
And I have this feeling that there is some correlation between that and the fact that there were tons of TV shows, around the time that I was a teenager, but they're still there, about really exciting careers in medicine and law that show women and men having, lives and status and doing really important things. And, I know lots of lawyers and doctors, and I know that I think being a computer scientist is a lot more interesting and a lot better job, a lot more creative than the jobs that many doctors and lawyers have. Why have we been so unsuccessful in getting the media, and particularly, Hollywood, to create sitcoms or adventure shows or reality shows even, whatever, around our field?
Well, I think it is a tough field because it involves... say somebody went over with a bunch of movie cameras into that Microsoft Office building. There would be some terminology that would, not.
You don't think this is true in medicine? Just imagine if you were really, really, looking at what's going on in surgery or in a dermatologist's office or lots of these things. It's actually, or go film a lawyer's office and watch what they're doing in a lawyer's office. It's...
If they really did, yeah. If they told the truth. Well, that's another approach, is to get the truth about these other professions out there.
Well, do you have any thoughts about what are more effective ways to get more women into computing careers? One of the things that's really depressing from my perspective is that computer science is the only field in science and engineering where participation of women has gone down over the last 25 years. So, for instance, if you look at mathematics, when I got my PhD in mathematics in 1977, I think it was about 11% of the PhDs went to women, and now it's over 30%. If you look at undergraduate degrees in mathematics, it's about 45%, and it was down around 10–15%. So in computer science, our figures are now about 15% of the PhDs go to women. About 15% of the bachelor degree recipients in research universities are women. It's just unbelievable how bad it is. We're down there. We're below physics in some cases. So what could we do to bring more? What would be effective in getting more women into these fields?
Well, I don't know the magic answer. I think everybody who thinks about the problem says you've got to get the women who are in the field to be more visible and get them...
No, that can't be the answer. Okay, raise your hand if you're a female here. All right. Are we being visible? Are we serving on every committee, going to all the schools?
Well, you're doing... It's good. You should keep doing that.
Yeah, we are going to keep doing it. But I hate to say it. We're not getting anywhere with it. The numbers...
I think if you weren't doing that, we'd be even worse off.
Yes, I'm sure. Yeah,
frank.
I think that's absolutely true. But, I'm sort of coming down to Hermione and Katie Holmes as my dreams for, computer science role models, because it's clear that the sort of things that we're doing on the grassroots level ourselves. I've been going out to the schools since I was 17 years old.
Okay.
I have never stopped doing presentations in elementary schools, high schools, middle schools. Every woman computer scientist I know is doing the same thing. So somehow there's got to be another way that we can succeed at this.
Well, I think that's one of the things. I think you've got to go. We've looked, as all these studies have, at what stages you lose people at, and unfortunately, you lose. You
lose them at every stage.
You lose at about 5 stages, and the cumulative effect is pretty incredible. And you get the fact that when the rich get richer and the poor get poorer. That is, if there aren't enough women in the field, then women find it unattractive simply because of that fact. If you got everything else right, and they said, oh, there's only 15% there, you might still lose just just because of that. And whereas if you got it up to 30%, then it would have a very different feel to it. So I think there is a critical mass element of this. I should know the numbers better. If you look in Asia, are they doing better on the male-female aspect?
No, and this is very depressing as well. So as part of a talk I was giving at ITISE, which is a computer science education conference in Europe, I tried to collect statistics on what the participation rates were around the world, and I certainly don't have the numbers. This is actually work done by a couple of sociologists and anthropologists who had collected the figures, and they had 22 countries, so it's not every country by any means. So the top 2 countries were Ireland and Turkey. Now, for Ireland, I had some conversations. Fortunately, there were some people from Ireland there, and they said that a part of it was that one is that this is the dominant economy in Ireland right now, and so. But the other thing is that because there's still a lot of single-sex education, and so girls, there's a lot of data that shows that single-sex education is more successful in keeping girls in math and science areas. Turkey, the reason is because you don't have a choice in Turkey. So in Turkey, you get, based on your exams, you get assigned to a particular program. And so they were producing a lot of women in computer science, but not because the women were choosing to go there. Even in those countries, they're up around the 30% range. Okay, and in many other countries, Germany's down around 9% and so on. So it seems to be a phenomenon worldwide. And at China, you can see, if you look at places like Jiaotong or Tsinghua and so on that are the elite schools, they're again down around 10 to 15% female. So it's a worldwide problem, and certainly one we're going to start on. Certainly one we're going to work on. I would be, I think, really remiss with this audience in the room if I didn't ask you some questions about your views on the future of innovation and technology. So I think everybody would want to ask you this. Of the many technologies that Microsoft is working on, which one excites you the most? Which one are you just completely passionate about?
Well, it's like asking me about which children I like
you're like
best.
2, yes.
Well, I can say without a doubt, the work of all the things going on in Microsoft, the work in Microsoft Research is not really the answer, but because they have a longer time horizon on the things we're doing, that is the most exciting thing. When I have time where Rick will bring in people to talk about their progress and what they're doing, that's about the funnest part of my job, is to sit and listen to that and think about how we take advantage of that. And people here probably know we have this thing called Tech Fest, where all the researchers essentially create booths, and all the product development people come, and it's over 10,000 go through and look at the ideas. And the energy and excitement around that makes that one of the funnest things on the yearly calendar. We have such a range of products. We have, this tablet PC is a very cool thing that eventually every student would just have a tablet.
Yeah, I've got one, and I love it, I have to say.
And the hardware is going to get dramatically better. The software is going to get dramatically better. So, that's something that I've been a personal advocate for internally, even against quite a bit of skepticism. And so, it'll take a number of years, but it's neat to see things coming into place for that. We have things like Xbox that, is just sexy because it's a video game. But even there, we had to invest billions of dollars. In the first generation of that, we knew we didn't have the credibility or even the skill set to be the leader. And so it took a lot of money and a lot of internal skepticism to say, should we be in this? And then say, no, if we do it well enough, what do we get? We get to play again. And so now with this second round, we're coming out with a product that's pretty good. And it sort of vindicates that level of investment that we made. And it's amazing how it's drawing on the deep technology that gets used in even something like that is pretty amazing, whether it's the communications or the graphics or the security or things of that nature. I've always had a small bias towards the things we do for people at work, because the impact Microsoft can have by making office work more effective, the way that people collaborate or know what customers are up to or plan projects, we can actually improve world productivity far better with what we do there than any of our consumer products. And actually, it's a field that there's this incredible vacuum. If you sit and say, okay, what company comes into work and thinks about, you know, making meetings more effective or getting rid of meetings in large part, or, you know, empowering people with information about what's going on, we're kind of in a unique position there, certainly in terms of really thinking about that and planning ahead. And so the dreams we have there about digital work style reach down all the way into the system. So, you know, how can a database let you find things? How can there be security that spans multiple organizations? You know, what are the new user interface techniques for these things? And so I've always been a champion of, okay, the consumer stuff is neat, we need to do that, but you know, let's keep business productivity in mind as well. And so we're an interesting mix where some areas like you know, parts of graphics, parts of database, tablet computing, we're kind of off on our own in terms of doing commercial products. And then we have a few areas where we have a competitor who's doing well, and we have to not only catch them but get ahead of them. So take web search would be an example of that. And that's fun too, because you have the target, you know, has been painted for you. You know what it is you have to match and exceed and get ahead of. And there's a certain dynamic in the team where you get together and say, okay,
go for it.
How are we going to beat these guys? Let's go do that. And so the way you manage the morale and excitement is slightly different between a team that's just, you know, trying to meet and exceed, where you know what you're doing, versus where you're out in the frontiers by yourself, just defining new areas. And you've got to make sure you've got a good balance of those, particularly the frontier things. You know, with Xbox, we're not just matching what Sony's doing. We're in the period where we're going out and really extending what can be done, and likewise with things like Office.
I think we probably have time for one last question, and so I'm going to save it for actually my favorite one. If you'd asked me what I thought would really make a difference in terms of getting more women into computing, one piece of it, I mean, I think there's a whole bunch of things. I think Rick Rashid actually has one of the best answers, which is make the first computer science class you teach the best computer science class you teach in each of our departments and in schools and so on. But the real question I want to ask, I think the other thing that will make a huge difference is, I personally believe that the most important thing we have to do today is use technology to address societal problems, especially in developing regions. And I know that the Gates Foundation has made this really a priority. And I would like to close by hearing some of your ideas about how our technology, computing technology, algorithms, software, hardware, all these kinds of things can address things like healthcare, education, water quality, all of those kinds of things. Do we have a role to play?
Yes, absolutely.
No, that's not enough.
No, I know. The lawyers always tell you, first you say yes or no, and then
oh, I see. Okay. Yeah, I haven't had as much experience there as you have.
No, I have. It seems, if you don't first say yes or no, they say it seems evasive, like you're trying to evade the question. So,
good, thank you. Yes, thank you.
And one of the coolest things I saw in the last few years was I was in Mozambique in an outpost called Manhissa, where they were doing some work on a malaria vaccine. And the key reason that this site could do this, well, first there was an incredible doctor from Spain who was there organizing it, but he had actually tracked the people in the village and their health history using a little PC access database. And so the ability to actually tell, you know, who was having fever, what was that caused by, and really prove out, was this drug working? It was really an IT thing, was the key thing that was missing there. And that's why that was one of few sites in the world that we could do this. And so sitting down and talking with him about, you know, what are your problems? How do you get support? How do you get connectivity? How can we make these things simpler? What's expensive? You know, it's fascinating. This technology, because it's now very low cost, high volume stuff, can reach out and be used basically anywhere in the world. The toughest problem we still have is the connectivity piece, and that's where work that I'm sure many people here are doing, Microsoft is very keen on, so-called mesh networking, where you can take the wireless spectrum and use that to get, particularly in areas with low density, very good connectivity at very, very low cost. That's a kind of a fascinating thing. Then there's other things about how you can make the computer better for that early education thing, make it more approachable, that type of stuff. If all we were doing, if the only thing we were doing in the field was providing computing technology to developing countries, it'd be worth it just for that. Likewise, if all we were doing was developing computing technology so the biologists would be able to collaborate and cure diseases and share ideas and model data, find patterns, things like that, if that's all we were doing, it would still all be extremely worthwhile. You know, that's a great field of endeavor, and that is one case where people who work on the boundary, you know, we need some of those. At the same time as we need people who work on our fundamental problems in order to build the tools that they need. So, you know, this is a field where, I'll just give one more example, where if you go to any of these countries and see where they have blind people or people who have physical disabilities, and you see how computers have come in to be the tool that lets, say, the visually impaired reach out and get any information on the internet, as opposed to in the past where their access to things that have been rendered into Braille were extremely limited. You can just go in and see that it's night and day. Their ability to communicate, collaborate, participate is phenomenal, and that's all because this is a field that's taken a very high volume, low price approach. It's driven breakthroughs, driven the prices down, and so it's, you know, it's very gratifying, and it's not just for the richest 2 billion people on the planet, although there's some neat things happening there. It's for the world at large.
Thank you.
Very much. We have some time for your questions. You'll see there are a couple of people with mics who are running around. Please grab a mic, and my request to you is please make it a question and make it short. Number one here, please. Yes.
Hi. You've talked a lot about computer science work. Could you say a little bit about the Technical Computing Initiative and what you think success will look like in 5 years from that work?
Yeah, one thing that I'm sure there's some breakout sessions on is that we're making a pretty dramatic step up of the investment we do in technical computing. It's been an area where Windows has participated in less than most other areas. It's very Unix, Linux oriented. So we think, hey, this is an important area. We'd like to improve Windows. We'd like to do some innovations on top of it that can fit into that area. To me, it's super interesting because a lot of these issues about parallelism, how you break problems down and describe problems that are going to occur all over the place, the frontier of that is in technical computing. And so, you know, when we take that 32 processor multi-core machine and say, okay, what are the compilation techniques, what are the programming techniques against them, even eventually for something like Microsoft Office, I think the answers to that will come out of this area of technical computing. It's also very interesting to us as we're trying to automate the management of data centers and have explicit models of what's going on in the data centers and how you allocate resources and reduce the amount of human effort in there. The kind of work that technical computing is doing, where you can abstract the problem, find the resources, if things don't go well, you know, do the dynamic adjustments without human intervention. Again, those are state-of-the-art software management type problems. And so we're very excited to be in that field, pushing some things forward and build up some collaborations that, in a very mundane sense, will drive our role in compute clusters up a bit, but in a more profound sense will influence the technology we're doing in all our products.
Number 3.
Hi, I'm Ben Shneiderman from University of Maryland. Thank you for a very interesting discussion, very productive, and I want to emphasize Maria's closing point that about new directions. I think everyone in this room can take pride for contributing to this remarkable growth, but in the same way, we haven't, I think, adequately adjusted to the maturation of the profession. And I think that's really the dynamics. The field is dominated and has the strongest of all professions studied of introverted personalities. And the sense of insularness among our colleagues, which limits exactly what you were suggesting of reaching out to the novel, challenging, and social aspects that I think the next generation of computing is all about. When, Bill, you mentioned with puzzlement about physical therapy or physical education, the growing fields are the caring ones, and those are caring for older adults, for example, and those who are engaged with other people. And so I think bringing computing into dealing with older adults, these issues of universal usability, the international development, conflict resolution, and also environmental concerns will generate not only enthusiasm among those who haven't been participants, but will really make our field relevant for the next 50 years. We really have to address what I think are the central issues of the next 50 years, building on the technical successes, but really focusing and making the visible part that makes the exciting television program our concern about the environment, about democracy, about voting, about older adults. You want to comment on that as a possible direction?
Well, yeah, is our field more introverted? It'd be interesting if there's some numeric measurement of that. I bet you if you went over and looked at that people in, say, that Microsoft Office development group, I don't think you'd find them particularly introverted. There might be maybe 10% of the people over there who are, just really like their code and work on their code and do a great job. And we love that 10%. But I'd be surprised if it was more than 10%.
It's not that they're extreme. It's just that compared to other professions, it has the highest degree of introversion. Their preference is to work on their own rather than to seek social participation. So that's why the field
I'm not sure anybody has actually watched a really large software project anymore because they're very large-scale groups of people trying to do something, working together.
Yeah.
Most of the issues in building large-scale software these days are how to get people to work together.
Yeah.
So,
if you compare it to most other professions, if you're a salesman, you just go find your customers, you sell to them. You're an isolated unit. The whole way that you work has been predefined. Whereas here, we're inventing new ways of coming together. I do think the field has to take on whatever's hot and explain how we make a big difference in whatever's hot. But I don't see how any other field has, when you talk about older folks and the medical challenges there. Like, it's either biology or computer science or the combination of those two that's going to make a difference there. I don't think any other field can even pretend to be in that discussion. If you take environmental issues, it's computer science together with basic meteorology, physics type things. It's going to make a difference there. So I'm not sure that we're failing to pander to these new things, and other professions are doing that better than us. Maybe I just take it for granted that people understand that those interesting issues are.
I don't think they do
science.
understand. I think that's what the real issue is, that most of the world does not understand that if you're going to work that if you want to solve these problems, this is one of the key techniques you have to have, and if you learn computer science, you're going to be in a great position to solve that. And so this is the dialogue I have all the time with students, because they don't understand the role that computer science is going to play in solving those problems. So whether we're introverted or not.
But the funny part about that, of course, is that everything these students use are the products of computer science. I mean, the cell phones, the instant messaging systems that they're using, the iPods that they're carrying around with them, the search engines that they're using. I mean, they're using all the tools and the results of the field of computer science. It's a critical part of. I mean, so much of the innovation, even the televisions now, whether it's Media Center or a TiVo, you're using computer science. The new standards for digital TV are all based on results from our field. So I think it's interesting in a way that you haven't been able to engage kids in the discussion to say, all these things that you use, don't you want to make them better?
Yeah.
Don't you want to add to that?
It is such a paradox. If you say to a kid, yeah, what are the 10 coolest products you use that, you know, your parents are clueless about, that, you know, you're good at using, I don't think they're going to say, no, you know, it's this new breakfast cereal and I want to go work in agriculture and invent new cereals or something, or, you know, the cars are so much different than before. You know, I think 10 out of 10 would be things that are software driven.
Number 2, please. Yeah.
This question is not dissimilar to the last one, but one of the things that you fail to use is the word enabling, and it seems like a little bit of navel-gazing to think about computer science being the center of things in the same way that we thought mathematics might be the center of things. So I have a question related to this. Computer science is really the modern mathematics. So why did Maria ask you about what the perfect engineer was, as you want the perfect computer scientist, not the perfect engineer? What's the answer to that?
I think we use these terms loosely.
I used it because Bill happened to say engineer in the preceding question rather than computer scientist.
Yeah, if somebody learns mathematics and then decides, okay, they're going to apply the understandings they have there and work in computer science, that's great. That's fantastic. We have no bias about whether they think of themselves as an engineer or mathematician or computer science. You know, we'll take the IQ that understands algorithms wherever we can get it.
Other questions? Yeah. Number 1, please.
When I talk to undergraduate students, or when I work with undergraduate students at Columbia, one of the most motivating things is when they actually have intrinsic or an extrinsic motivation. We have lost the people who got into computer science because they could earn millions and be billionaires immediately after graduation, but we have kept the ones that have intrinsic motivation. One of the things that motivates them is the ability to participate in projects which reach beyond their narrow confines. That's why I believe that, for example, open source projects are so popular among the college population. But then they see job offers, and what they have to work on are how do I make some random bank, New York being where we live, richer, or how do I build a digital rights management system to prevent access to media. All of these things, there's a dichotomy between the intrinsic motivation and the real job prospects on that. And I've heard a lot of frustration among students that they don't really see themselves contributing more than a salesman would to the bottom line of a shoe manufacturer.
Well, I think it's a good point that you want to connect up to somebody's aspirations to change the world. And certainly when I think about the jobs here at Microsoft, because people have so many choices, they can you know, think about, hey, if Office is a better product, you know, great, that's influencing people in a fairly dramatic way. Or if I'm the one who's thinking about how this technology gets applied to education or various fields. If you do go to work for a bank doing computer software, you know, I'd say that's better than going to work for a bank doing anything else in terms of your mind getting exercised and being able to actually make that bank more friendly or more efficient so they offer products at lower prices. I agree there's a bit of a discontinuity between sitting in the university thinking, okay, I'm going to build the next operating system that hundreds of millions of people are going to use, and then a lot of the job offers that you get. That comeuppance exists in many fields. We should try and make it the smallest in this field, because I actually believe, how many fields can you get right out of college and define substantial aspects of a product that's going to go out and over 100 million people are going to use it? We promise people when they come here to do programming, we promise them they're going to have that opportunity. And yet we can't hire as many people as we'd like. So, but we do make a move. It's hard for them to stay in New York and do that. So.
But I'll just add that I think every field has to be, in some sense, part of what you have to do in each field is, if you really want to be able to attract the best and the brightest students, you have to have the story, the romantic story about what it is you're trying to do and what it is you're trying to accomplish. And no, I mean, if you look at 30,000 students that might be in that particular discipline, they're not all going to be the ones that are on the frontier when they get their jobs. And that's just the way the world works. I mean, if you go into medicine, everyone isn't going to be the person that invents the new vaccine that saves the world. That's just not how it works. A lot of people are doing fairly routine things and pushing paper around. So I think part of it is an issue of how do we make sure that computer science is competitive with the other disciplines in terms of making sure that students really understand that there is a set of great things that the field is trying to accomplish. It is not just here are these very mechanistic processes that we want someone to be able to do for us, but that in addition to those more mundane things, there are great problems that the field is trying to solve. There are great opportunities for affecting people's lives in an important way, and that if you can aspire to that much the way you can aspire to success in any of these other disciplines.
Question here, 3, please.
There was an article in the New York Times yesterday about people being frustrated with all the adware and spyware on their computers to the extent that they would throw the computer in the garbage and buy a new one. I was wondering, obviously it's a little drastic, but what is our progress on security and privacy for computers? Do you think we'll be turning that around, and what are the steps required to do that?
Well, there's no doubt that the digital domain is big enough now that you've got all sorts of people who seek to abuse it, whether it's identity theft or spam or these other things. And so it's kind of a measure-countermeasure game that we're in. And it's a great example of where fundamental ideas in computer science can make a very big difference. If you take one of the fronts, which is spam, I'd be very optimistic. Over the last couple of years, we've made good progress. If you're on a system that has the right type of filtering, IP address checking, spam is down dramatically from its peak. Now, some people are still on systems that don't have those abilities. We need to connect those up. There's still some additional techniques in terms of proof of who's sending it and tracking behavior that we're applying over the next 12 months that I think will make a big difference there. Likewise, on this whole spyware thing, the laws are now clear. That's been a huge advantage for us because we have a piece of software that goes and cleans, does these scans and cleans the software off of systems. And as new software shows up, we have this thing called SpyNet where people rate what their experience in using the thing was. So the pioneering users basically lend to the non-pioneering users the understanding of, hey, should I think this is really a screensaver or really a poker game, or is it really something else? And so I'm very optimistic that when we talk about this digital decade and digital work style lifestyle, that those security things won't hold us back. Now, having said that, it is the biggest area of R&D investment we have. If you look at, at the very particular level at, say, the schedule for the next version of Windows, the biggest thing that we've done in that release is the security work. And the biggest thing that, between now and the time we release it, we have to do is make sure that we've done that security work in a way that's very approachable and dramatically improves the experience that people have in those areas. So that looms as a thing that could hold us back as a field, but I'm quite sure that it won't because of the priority we're giving to it and because of basic research results that we can apply for these problems.
Number 2, please.
I was wondering when you count the decreasing number of people that affiliate with computer science, if it's not a matter of actually counting the wrong thing, because computer science in many respects has been a victim of its own success, and now it's so pervasive that people that want to study computer science end up very often doing computer science under a different name in different departments sometimes. For example, in mechanical engineering at Cornell, where I'm from, all the students now learn, it's a required course, they learn how to program embedded systems. So, for example, people that are interested in that thing might end up not showing up on your radar, where they're actually the kind of people that you're looking for.
Well, if we're missing people out there who've got the right skill sets, shame on us and clue us in here. This is a good opportunity. Just selfishly, we want to fill these jobs and have these projects move ahead at full speed. and we think we're looking at the job pool the right way. I mean, certainly, these are very high-paying jobs. If you take computer science jobs that you can get right out of college, we'll always be, because we want to get the very best, we'll always have the most attractive economic offer. And so you'd think the marketplace would help these people find their way to us, even if we're not being too clever about it. But talk to us about where we should be looking. We're trying to cast our net as wide as possible.
So I'd like to address that for a moment. Obviously, as the Dean of Engineering, we have a mechanical engineering or mechanical and aerospace engineering department, and I think it's a great department, but there's absolutely no way that the students who are going through the mechanical engineering program at Princeton, unless they're taking a lot of computer science courses on the side, are getting the same depth of learning in computer science. And so the other thing I'd like to say is that overall interest in engineering is down, not as dramatically as computer science is, but in the U.S., interest in engineering has been going down for several years. And so it's not that I want to say that you couldn't get a fabulous person to hire out of mechanical engineering. I would put many of my mechanical engineering graduates up against any of the other graduates from the engineering school. I mean, they're bright and so on, but they certainly don't have the same set of background. And I guess the thing I think is that I'd love to see more people who are between computer science and mechanical engineering, or computer science and chemical engineering, or any of those kinds of things. But if all they're taking is basically 1 or 2 programming courses, they're not going to have the same depth of algorithmic or architectural understanding that I think people would be looking for.
Number 1 there, please.
I'd like to trot out one of my favorite hobby horses, get an opinion on it, and that is that I think that computer science today is shooting itself largely in the foot by teaching what is becoming a commodity skill, which is largely programming and software development. And I have been lobbying in my own department for some years that we should change our curricula to focus on design and generation of intellectual property and stuff like that. And I wonder if that has any role in maybe increasing participation by other underrepresented groups, and if it would make people more attractive to Microsoft for their jobs.
Well, help me understand. Now, keep the microphone. What's the difference between learning to do design and learning to do programming?
You want me to keep on answering?
Well, just
go for it, Jim.
Draw the distinction for me, because I have to say, I think you've got to spend years writing programs and having them critiqued, having people say, hey, that was a bad way of doing that data structure, a bad way of doing that algorithm. I think you have to write code and have people say, hey, this isn't as good as you think it is, before you have a sense of being able to step back and do good design. Is that wrong?
Actually, you're absolutely right, Bill.
Okay.
Good programming is design.
I have an answer to my question.
Well,
the problem is that most of the training in programming becomes not design. You think I need the mic? This is the first time anybody's ever told me I need a mic. But unfortunately, Maria made a point earlier that she said, Rick said that the best course, the way to get people into computer science is to do the first course best. I think we don't do that. I think that we teach programming in the first course, and we teach it at a level where they're not doing design, where they're just memorizing patterns and then trying to go into the exam and match the pattern to the pattern that they were taught and have no idea about this concept of design. I think Jim's point is right on target as far as, actually it's your point that's right on target, that good programming is design, and to teach programming correctly is as big a design challenge as teaching any engineering course.
Yeah. Well, to be clear, we want design. That's what we want. We want people who are good at design, because we're not doing repetitious programming. We're always, pushing out to something that has to be designed. And when we get programmers in here, it's not the number of lines of code they can turn out. That's not interesting. It's what kind of reuse and architecture do they go about creating. I think this point about the first computer science course is a good one. My knowledge is very archaic. But I would say the early computer science courses definitely favored people who want to stay up all night and work ridiculous hours and get in to learn mundane details and things like that. It definitely did give an impression of the profession that fits more to the stereotype than the reality. So I think...
Well, yeah, and I think part of the problem, too, is that a lot of times these early computer science courses are basically just teaching programming. They're trying to teach somebody how to do a particular skill, and they don't even bother to explain why. I mean, what was it that you were supposed to want to do that this skill was needed for? I mean, there's very little that's conveyed as part of that first course that says, these are the exciting things that if you develop these skills, you will be able to do. And,
skill like they're teaching you how to drive a car. And that's not what you guys are after. You're after guys.
It's okay, we're on the West Coast. Guys are female as well.
Yeah. But a lot of, right. You're looking for people that are more than just memorizing how to drive a car. We're back to this design thing, and it has to be done, I think, right from the get-go.
Well, and I think also if you look at the way the profession is changing, increasingly the skill set and the design abilities and the abilities to work collaboratively in groups to accomplish something, that whole set of skills is moving up. If you look at the jobs we hire into at Microsoft today, there used to be a number of we have a technical level system that we employ. There were a number of lower technical levels we don't even hire into today, largely because they've been automated out of existence. We now expect people to know a lot more, to be able to do a lot more, because the software we write demands a greater level of expertise. And again, I think that's a great thing in terms of trying to talk to students about what they can accomplish, what they can do. But it means that the educational system has to change in terms of how do you get the right students into the system, and how do you get them the right skill sets to be able to be successful. And it's not just about sitting down by yourself and writing some C code, because that's not what jobs look like very much.
So when I talk to your managers who are out there recruiting, they say that their biggest problem is, when I talk to your managers who are out recruiting, they say their biggest problem is that they're not able to hire people that have that fundamental deep understanding of the underpinnings, and that too much of the education is at this higher level, which doesn't take you anywhere, because if you don't understand it at a deep level, then you can't move the fields forward.
So I think that would be the last question. We have run out of time, so I apologize to those of you who couldn't get the question in. And with that, I'd like to thank the participants, and Maria especially, for making this a success. And thank you. And now we'd like to recognize the winners of the first New Faculty Fellowship Award. So